Today, we are looking at the basic element of the programming language Python. First, we will be exploring values and their type. Then we will tackle the concept of variables and how they assign them a value. To better understand the state of the program, that is, the value assigned to the variables declared in the program, I'll introduce the notion of state diagram. A value is one of the fundamental things that a program manipulates. A value can be a letter like B, or a word like Lillian, a number like 1 or 3.14, or a more complex data type that we will explore in later videos. Values have a type. For example, 1 and 1.0 are not represented in the same way in memory. They have a different type. Words and letters are string, noted str in Python. In Python, you can use either a pair of double quotes or a pair of single quotes to represent a string. To find the type of a value, you can use the instruction type with the value between round brackets. In our example, we can see that the type is a string noted str in Python. Numbers with a decimal points are called floats. In Python, minus 124.0 or 0.123 are floats. For example, again, using the type function, we can see that 119.0 is a float. Integer, int, in Python are whole number, positive and negative. For example, 1, minus 124, or 0. Note that you must not add a decimal point. Again, using the function type, we can see that 190 without a decimal point is an int. What about the value like 17 between quotes? They look like numbers, but they are in quotation mark, like string. Be careful, these are not int or float number, they are strings. This is a common source of error and confusion for the novice programmer. A critical aspect of programming is the means it provides for using name to refer to a computational object. One of the most powerful features of a programming language is the ability to manipulate variables. We say that the name identifies a variable whose value is the object. Python uses the assignment operator, equal, to link a variable to a value. The assignment statement creates a new variable and links it to a value. The assignment operator, equal, should not be confused with an equality operator, even though it uses the same symbol. The assignment operator links a name on the left-hand side of the operator with a value on the right-hand side of the operator. Variables have a type, and the type of a variable is the type of the value it referred to. A common way to represent variable on a paper is to write the name with an arrow pointing to the variable value. This kind of figure is called a state diagram because it shows what state each of the variables are in. Think of it as a variable state of mind. On the left-hand side, we have the interpreter, and on the right-hand side, we have the memory space. This is a simplification of the memory space. It does not accurately show how data is represented in a computer memory. And finally, the namespace, where variable names are represented. In the interpreter, you have an assignment statement which assigns a string to a variable. The assignment operators always evaluate its right-hand side first. So the string Lillian is first stored in memory at some address. Then, the name of the variable is added to the namespace. Finally, the value is assigned to its variable. We represent the assignment operation with an arrow pointing from the variable name to the object in memory. The same thing applies for the next two assignment statements. The next statement calls the print function with the variable called name. First, the interpreter evaluates what is between the round bracket, that is, the variable name. The interpreter looks if such a variable exists in the namespace. Once found, it fetches the value referenced by the variable. In other words, it follows the arrow. In this example, the value referenced by the variable name is the string Lillian Blot. It then replaces the variable name by its value in the section and prints the string Lillian Blot. There are some constraints on the naming of variable. Variable's name must start with a letter or underscore. Variable names can contain letters, number, and underscore. Variable names can be arbitrarily long. The Python language is case sensitive, which means size in lowercase and size in uppercase are two different variables. By convention, uppercase letters are not in use. For readability purposes, it is common to use longer names for variables representing some data. For example, the title of a book or the book's price can be represented using multiple words in the variable name. However, white space are not allowed in a variable name. Therefore, multiple word variable names use underscore to separate words. For example, book underscore title or book underscore price could be the name of a variable representing the title and the price of a book. Note that some Python libraries use a different convention that separates words by an uppercase letter instead of an underscore. For example, the variable book title uses an uppercase T with no space or underscore between book and title. In addition, language rules and structure are defined by keyword. Such keyword cannot be used as variable names. The table shown here contains the 33 keywords used by the Python 3 language. We have seen how to create variables and assign them values of different types. In the next video, we will be looking at creating more complex expressions using values, variables, and operators.